thoroughness of service upgrade inspections can vary depending on the inspector, the local building codes, and the specific circumstances of the property. Generally, a service upgrade inspection should include a visual inspection of the meter socket. This involves checking for proper grounding, wire terminations, and any signs of damage. A thorough inspection of the electrical panel should also be performed. This includes counting circuits, examining wire connections, verifying breaker ratings, and checking for any overloads. Verification of drainage holes is another important step, ensuring that exterior light boxes have drainage holes to prevent water accumulation. A review of the electrical system diagram, if available, helps to understand the overall layout and any potential issues. Verification of permits and documentation is also crucial, checking that the necessary permits have been obtained and that the work is being performed by licensed electricians. In some cases, inspectors may also perform load calculations to determine if the existing wiring and panel are adequate for the new service. They might also inspect the grounding system to verify that it meets code requirements. Testing the electrical system is also a possibility to ensure that it is functioning properly and meets safety standards. It's important to note that while a brief inspection may identify major safety concerns, it may not uncover all potential issues. If there are any concerns about the thoroughness of the inspection, a more detailed examination can be requested. Ultimately, the best way to ensure the safety and reliability of a service upgrade is to hire a reputable and experienced electrician who will perform a thorough inspection and obtain the necessary permits. Electrical inspections serve as a critical safeguard for properties. These inspections meticulously assess electrical systems to ensure compliance with safety standards and regulations. A comprehensive electrical inspection typically involves a detailed examination of various components, starting from the service entrance where electricity enters the building. This includes the meter socket, which houses the electrical meter that measures energy consumption. Inspectors verify the integrity of the socket, checking for any signs of damage, corrosion, or improper connections. Grounding systems are also closely scrutinized to ensure they provide a safe path for fault currents, minimizing the risk of electric shock. The inspection extends to the main electrical panel, the central distribution point for electricity throughout the building. Here, inspectors meticulously count the number of circuits, verifying that they are properly labeled and protected by circuit breakers or fuses of the correct amperage rating. They examine wire connections to ensure they are tight and secure, preventing overheating and potential fire hazards. The condition of the wiring itself is also assessed, looking for any signs of deterioration, damage, or improper installation. In addition to the main panel, inspectors also examine subpanels, which are smaller distribution panels located in other areas of the building. They repeat the same inspection procedures for subpanels as for the main panel, ensuring that all circuits are properly protected and wired. Wiring throughout the building is inspected for proper installation, support, and protection. Inspectors check for loose connections, damaged insulation, and any signs of overheating. They also verify that wiring is properly sized for the intended load, preventing overloading and potential fire hazards. Electrical outlets and switches are tested to ensure they are functioning correctly and safely. Inspectors check for proper grounding, loose connections, and any signs of damage. They also verify that outlets are properly spaced and located according to code requirements. Lighting fixtures are inspected for proper installation, wiring, and grounding. Inspectors check for damaged or missing parts, loose connections, and any signs of overheating. They also verify that lighting fixtures are located in safe areas, away from flammable materials. Ground fault circuit interrupters, or GFCIs, are special types of outlets that are designed to protect against electric shock. Inspectors test GFCIs to ensure they are functioning properly, particularly in areas where water is present, such as bathrooms and kitchens. Smoke detectors are essential safety devices that provide early warning of a fire. Inspectors test smoke detectors to ensure they are functioning correctly and located in appropriate areas. They also verify that smoke detectors are properly powered and interconnected, so that if one detector sounds, all detectors will sound. Carbon monoxide detectors are designed to detect the presence of carbon monoxide, a colorless, odorless gas that can be deadly. Inspectors test carbon monoxide detectors to ensure they are functioning correctly and located in appropriate areas. They also verify that carbon monoxide detectors are properly powered and maintained. Electrical appliances are inspected for proper wiring, grounding, and operation. Inspectors check for damaged cords, loose connections, and any signs of overheating. They also verify that appliances are properly used and maintained. The inspection process also includes a review of electrical plans and permits. Inspectors verify that the electrical work was performed according to approved plans and that all necessary permits were obtained. They also check for any outstanding electrical violations or code discrepancies. Upon completion of the inspection, the inspector provides a detailed report outlining any findings or recommendations. The report may include a list of electrical violations, safety hazards, or areas that need improvement. The report is typically provided to the property owner or manager, who is responsible for addressing any issues identified in the report. Electrical inspections are essential for ensuring the safety and reliability of electrical systems. By identifying and correcting electrical hazards, inspections help to prevent fires, electric shocks, and other electrical accidents. Regular electrical inspections can also help to extend the life of electrical equipment and reduce energy costs. For example, identifying and correcting loose connections can prevent overheating and reduce energy waste. Electrical inspections are typically required for new construction, renovations, and property sales. They may also be required periodically as part of a regular maintenance program. The frequency of electrical inspections may vary depending on the type of property and local regulations. It is important to hire a qualified and licensed electrical inspector to perform the inspection. A qualified inspector has the knowledge, experience, and equipment to properly assess the condition of the electrical system and identify any potential hazards. The inspector should also be familiar with local electrical codes and regulations. When hiring an electrical inspector, it is important to ask for references and check their credentials. You should also ask for a detailed estimate of the inspection cost and the scope of the inspection. During the inspection, it is important to be present and ask any questions you may have about the electrical system. The inspector can provide valuable insights into the condition of the electrical system and offer recommendations for improving safety and efficiency. After the inspection, it is important to review the inspection report carefully and address any issues identified in the report. You should also keep a copy of the inspection report for your records. Electrical inspections are an important investment in the safety and well-being of your property. By ensuring that the electrical system is functioning properly and safely, you can protect your family, employees, and property from electrical hazards. In addition to regular electrical inspections, it is also important to practice electrical safety in your home or workplace. This includes avoiding overloading circuits, using extension cords properly, and keeping electrical appliances away from water. You should also have a qualified electrician perform any electrical repairs or installations. Service upgrades are significant modifications to a building's electrical system. These upgrades are typically undertaken to increase the capacity of the electrical service, allowing for the use of more electrical appliances and equipment. Service upgrades involve replacing or upgrading the main electrical panel, service entrance conductors, and metering equipment. The process begins with an assessment of the existing electrical system to determine the current load and the required capacity for the upgrade. This assessment takes into account the size of the building, the number of occupants, and the types of electrical appliances and equipment that will be used. Based on the assessment, a new electrical panel is selected with the appropriate amperage rating and number of circuits. The service entrance conductors, which connect the electrical panel to the utility company's power lines, are also upgraded to handle the increased load. The metering equipment, which measures the amount of electricity consumed, may also need to be replaced or upgraded. Before any work begins, it is essential to obtain the necessary permits from the local building department. These permits ensure that the work is performed according to code and that the electrical system is safe and reliable. The service upgrade work is typically performed by a licensed electrician who has the expertise and experience to handle the complexities of the project. The electrician will disconnect the existing electrical service, remove the old equipment, and install the new equipment. The new electrical panel is carefully mounted and wired according to code requirements. The service entrance conductors are connected to the new panel onto the utility company's power lines. The metering equipment is also connected and tested to ensure it is functioning properly. Once the service upgrade is complete, the electrician will perform a thorough inspection to ensure that all connections are tight, all components are properly grounded, and the electrical system is functioning safely. The electrician will also label all circuits in the new panel and provide a circuit directory for future reference. After the inspection, the electrician will request an inspection from the local building department. The building inspector will verify that the work was performed according to code and that the electrical system is safe and reliable. If the inspection is approved, the building inspector will issue a certificate of occupancy, which allows the building to be occupied. Service upgrades are a significant investment, but they are essential for ensuring that a building's electrical system can safely and reliably meet the demands of modern electrical appliances and equipment. Service upgrades can also increase the value of a property and make it more attractive to potential buyers. When planning a service upgrade, it is important to choose a qualified and licensed electrician who has the experience and expertise to handle the project. The electrician should be able to provide a detailed estimate of the cost of the upgrade and a timeline for completion. The electrician should also be able to obtain the necessary permits and coordinate with the local building department. During the service upgrade, it is important to minimize any disruptions to the building's occupants. The electrician should work efficiently and safely to complete the project as quickly as possible. The electrician should also take steps to protect the building's occupants from electrical hazards. After the service upgrade is complete, it is important to properly maintain the electrical system to ensure it continues to function safely and reliably. This includes periodically inspecting the electrical panel, checking for loose connections, and replacing any damaged components. It is also important to avoid overloading circuits and to use extension cords properly. Load calculations are a critical aspect of electrical system design and installation. These calculations determine the amount of electrical power that a building or electrical system will require to operate safely and efficiently. Load calculations are used to size electrical panels, service entrance conductors, feeders, branch circuits, and other electrical components. The process begins with an assessment of the building's electrical needs. This assessment takes into account the size of the building, the number of occupants, the types of electrical appliances and equipment that will be used, and any future electrical loads that may be added. The electrical load is divided into two categories: continuous loads and non-continuous loads. Continuous loads are those that operate for 3 hours or more at a time, such as lighting, heating, and air conditioning. Non-continuous loads are those that operate for less than 3 hours at a time, such as appliances, power tools, and equipment. The electrical code provides specific guidelines for calculating the demand factors for various types of electrical loads. Demand factors are used to reduce the calculated load to account for the fact that not all electrical loads will be operating at the same time. For example, the demand factor for lighting in a residential building is typically lower than the demand factor for lighting in a commercial building. The calculated load is then used to determine the size of the electrical panel, service entrance conductors, feeders, branch circuits, and other electrical components. The electrical components must be sized large enough to handle the calculated load safely and efficiently. The electrical code provides specific requirements for the sizing of electrical components. For example, the service entrance conductors must be sized to carry at least 100% of the continuous load plus 125% of the non-continuous load. Load calculations are typically performed by a licensed electrician or electrical engineer. These professionals have the knowledge and experience to accurately assess the electrical needs of a building and to properly size the electrical components. Load calculations are essential for ensuring that a building's electrical system can safely and reliably meet the demands of its electrical loads. Overloading an electrical system can lead to overheating, damage to electrical components, and even fire. Proper load calculations can prevent these problems and ensure that the electrical system operates safely and efficiently. When planning an electrical installation or upgrade, it is important to have a qualified professional perform load calculations. The load calculation should be reviewed by the local building department to ensure that they comply with the electrical code. During the electrical installation or upgrade, it is important to follow the load calculations and to use electrical components that are properly sized. The electrical system should be inspected by the local building department to ensure that it is installed correctly and that it meets the requirements of the electrical code. After the electrical installation or upgrade is complete, it is important to periodically review the load calculations to ensure that they are still accurate. If the electrical loads of the building have changed, the load calculations may need to be revised. Grounding is a critical aspect of electrical safety. It provides a path for fault currents to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Grounding systems consist of a grounding electrode, a grounding conductor, and equipment grounding conductors. The grounding electrode is a metal rod, plate, or other conductor that is buried in the earth. The grounding conductor connects the grounding electrode to the electrical panel. The equipment grounding conductors connect the metal parts of electrical equipment to the grounding system. When a fault occurs, such as a short circuit, the fault current flows through the equipment grounding conductor back to the grounding electrode. From the grounding electrode, the fault current flows back to the source through the grounding conductor. This flow of fault current trips a circuit breaker or fuse, disconnecting the circuit and preventing electrical shock. Grounding systems are required by the electrical code for all electrical systems. The electrical code specifies the type and size of grounding electrode, grounding conductor, and equipment grounding conductors that must be used. Grounding systems must be properly installed and maintained to ensure that they function properly. The grounding electrode must be buried deep enough in the earth to provide a low resistance connection to the ground. The grounding conductor must be securely connected to the grounding electrode and to the electrical panel. The equipment grounding conductors must be securely connected to the metal parts of electrical equipment and to the grounding system. Grounding systems should be inspected periodically to ensure that they are functioning properly. The grounding electrode should be checked for corrosion and damage. The grounding conductor should be checked for loose connections and damage. The equipment grounding conductors should be checked for loose connections and damage. If any problems are found with the grounding system, they should be repaired immediately by a qualified electrician. Ground fault circuit interrupters, or GFCIs, are special types of outlets that are designed to protect against electric shock. GFCIs work by monitoring the current flowing through the circuit. If the current flowing out of the outlet is different from the current flowing back in, the GFCI will trip, disconnecting the circuit and preventing electrical shock. GFCIs are required by the electrical code in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor areas. GFCIs should be tested periodically to ensure that they are functioning properly. To test a GFCI, plug a GFCI tester into the outlet and press the test button. The GFCI should trip, disconnecting the circuit. If the GFCI does not trip, it should be replaced by a qualified electrician. Electrical permits are required for most electrical work. Electrical permits ensure that the work is performed according to code and that the electrical system is safe and reliable. Electrical permits are typically required for new electrical installations, electrical alterations, and electrical repairs. The process of obtaining an electrical permit typically involves submitting an application to the local building department. The application must include detailed plans of the electrical work to be performed. The building department will review the plans to ensure that they comply with the electrical code. If the plans are approved, the building department will issue an electrical permit. The electrical work must be performed by a licensed electrician. The electrician must follow the plans and the electrical code. After the electrical work is complete, the electrician must request an inspection from the local building department. The building inspector will inspect the electrical work to ensure that it was performed according to code and that the electrical system is safe and reliable. If the inspection is approved, the building inspector will issue a certificate of occupancy. Electrical inspections are an important part of the electrical permit process. Electrical inspections ensure that the electrical work was performed according to code and that the electrical system is safe and reliable. Electrical inspections are typically performed by the local building department. The building inspector will inspect the electrical work to ensure that it was performed according to code and that the electrical system is safe and reliable. The building inspector will check the electrical panel, the wiring, the grounding system, and the electrical outlets. The building inspector will also check to make sure that the electrical work was performed by a licensed electrician. If the inspection is approved, the building inspector will issue a certificate of occupancy. Licensed electricians are required to have the knowledge and experience to perform electrical work safely and reliably. Licensed electricians must pass an exam to demonstrate their knowledge of the electrical code. Licensed electricians must also complete continuing education courses to stay up to date on the latest electrical codes and technologies. When hiring an electrician, it is important to check their license to make sure that they are qualified to perform the electrical work. You can check an electrician's license by contacting the local building department. Reputable electricians will provide references and be happy to show you examples of their work.